All right, so we're starting a new unit today. It's for functions, and it's going to start out with some graphing relationships. So you have a note sheet that was passed out to you, and on the back of the note sheet is your assignment. So first we're going to go over the notes, and then we'll look at a couple examples, and you'll be clear to go work on your assignment. So let's look at some vocabulary first. We're talking here about independent variables. So variable is just a letter that indicates a number. We talked about those before. And a variable, the independent one, is a variable whose variation does not depend on that of another. Depend on that of another. Okay, it's always written in the bottom of the graph, and so it's typically your x value. And so it's typically your x value and your input when we're talking about functions. Okay, so those are some key points. So an example, let's draw a line across here. An example of an independent variable is something like time or age, those kinds of things that will be on the bottom of your graph. Now, a dependent variable is a variable whose variation does depend on that of another. So that's your output when you're talking about a function. It's the number you get when you put it through the equation. It's typically on the left or the right side of the graph, depending on what kind of graph. And if you're considering outputs, these are things like the temperature and the distance. So after you put the time in, you would find out how far someone ran, for example. So the time is the independent and the distance is the dependent. Okay? Now, we're going to look at this. A continuous graph is a graph that is made up of a single line of connected points. So, for example, if we have a graph, it could look something like this. And this is continuous. It keeps going, so that would be considered connected, so it would be continuous. Okay? And then a discrete graph is a graph that is made up of a set of points. And so that's more like a scatter plot. All right? So we would have a graph, we would have points here, 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 and then we would determine how those points are related. Okay? Now, some important key points or key things to remember. When you're reading a graph, you always read from left to right. Always read from left to right. And then also look for changes in the graph. Okay? And use those changes to figure out what's going on in each section. So you can list look for changes. List the changes in order, okay? And use this to determine what's going on your graph. So, for example, in the one I drew here, something's happening at this point, right? It's going up, oh, then it starts going down, okay? So we would look for changes, find that change, and then talk about what's causing that to go up and then go down, okay? That's what we're talking about with looking at the graphs, okay? Now, when we're translating from words to looking at a graph or talking about a graph and going backwards, we're going to look at for these kind of keywords. If something is constant, you are looking at a horizontal line. Okay, if we say it was constant, doesn't change, it's horizontal line. Or if we say it stayed the same, horizontal line. Those are words that would indicate you're looking at a horizontal line. Okay, if it rises steadily, then you're going diagonal up. Remember, left to right. Okay, and if it drops steadily, you're going diagonal down. Left to right. And then if it rises sharply, you're curving. Curved line going up. Curved line going up. And if it drops sharply, curved line going down. Like so. Okay? So make sure you have all those notes. If you need to stop the video, go ahead, and then we're going to go over some examples. All right, so a couple examples. These are not on your paper, but if you want to write them in your notebook, that would be probably a good idea. We're just looking at what kind of a graph is in this example, okay? So the air temperature was constant for several hours. So constant, that means there's going to be a horizontal line somewhere. And then it rose steadily, and that means there's going to be a diagonal line going up. And then it stayed the same for most of the day before dropping sharply. So it stayed the same again. So then we've got stayed the same, another horizontal, and then it dropped sharply, which is curved down. So think about that. Constant, rose steadily, constant, sharp. Okay? And then you look at these, and which one of those graphs kind of has that shape? We're looking at graph C. See that? Oh, I'm sorry, that's not right. Rose sharply, let's see here. It should be, let's see. It was constant, rose steadily. Constant, rose steadily. It would look more like this. I'm not sure if it looks like really any of those. I guess it could be somewhat more like B, but I'm thinking it should have been up and then a curve down based on what we talked about in the previous. So B is probably the closest, okay? Because it stayed the same most of the day and then it went down. So those are the kind of shapes when you're looking at the graph, you want to do your shapes. So the example 2, we're going to match the situation with the graph. A car is traveling 23 miles per hour, so it's going at a steady speed, going up, right? And it accelerates to 45. So it's going at 23, and then it starts at 23. Here's 23 right there, and this one's got a 23. So it's going at 23, and then it accelerates to 45. This is 45, and this is 45. I don't think it's this one, and it's not going slow, okay? So for the first one, we'll look at this. It goes up within 5 seconds. So here to here is 5, and then see this one, traveling at 23, it maintains the speed for the next 5 seconds, and then it slows down to a stop in 5 seconds. So that looks like this guy here. I'm going to say that's D, okay? Because this one doesn't stop. This one stopped, but it was decreasing. So then we look at this. A car at rest accelerates to 23. That's this one, rest, to 23. And then it maintains that speed for 5 seconds. And then it accelerates to 45 and slows during the next 5 seconds. Then accelerates to speed to 45 and slows during the next 5 seconds. Okay. This one, but it's going to be, then it needs the slows. This would have this, but we'll say C. And then a car travels at 23 for 5 seconds, 23 for 5 seconds. And then it accelerates to 45 or the next 5 and it maintains that speed for 5 seconds. So that's a D. And then a car traveling at 45 slows. So then The last one, it travels at 45, then it slows down, 23 for 5, and then it maintains for the next 5, and then it slows down to stop. So that would be A. All right, so that's kind of how modeling how you would think about them and go through the graphs. And then example 3, we're selling chocolate to raise money for school. For each box he sells, the school will get $10. Draw a graph that shows how much money the school will make as he sells more chocolates over time. So if you think about this, right, he's going to sell boxes, and for every box he makes $10. So this is 10, 20, 30, okay? So the first box he makes 10, the second box he makes 20, the third box he makes 30. So our graph really is going to look like that. Okay, it's going to be linear. For every box he makes another $10. All right, so that's just how you would think about the graph. These don't have to be exact. You're more looking at the shape, okay? This would be a linear graph. So that's what you're kind of looking at. We're going to get into graphing specific things a little bit later. All right, so go do your classwork, and we'll see you tomorrow for the next video.